Hello, welcome to Make to Explore. In this video, we're going to make one DIY project, GPS Speedometer. A GPS speedometer is a device or application that uses the global positioning system to determine and display your speed in real time. Unlike traditional vehicle speedometers, which relies on the rotation of the wheels via speed sensors or a mechanical connection, a GPS speedometer calculates speed based on satellite signals that track your movement over time. So let's get started and see the hardware setup of the project. So we're going to use M5 StickC+2 development board and Unit GPS Satellite Positioning Module, which has built-in AT6558 high-performance navigation chip that supports multiple satellite navigation systems. Let's see about these hardwares in detail. So, this is a documentation guide of M5 StickC+2 board. Let's see what they said here. The StickC+2 is an iterative version of the StickC+. Let me show you its earlier version. So, this is a StickC+. We also have tutorials and projects planned for this version of development board. Please stay tuned. Let's get back to our main board for this project. This is StickC+2. Its main control uses the ESP32 Pico V302 chip, which supports Wi-Fi. Inside its compact body, it integrates a variety of hardware resources such as infrared, RDC, microphone, LED, IMU sensor, buttons, and buzzer. It also features a 1.14-inch TFT screen, driven by ST's 7789V2 driver, with a resolution of 135 by 240. The battery capacity has been increased to 200 mAh. This compact and exquisite development tool can unleash unlimited creative potential. StickC+2 can help quickly build IoT product prototypes, greatly simplifying the entire development process. Even beginners who are just starting to learn programming can use it to build some interesting applications and apply them to real-life scenarios. Let me show you the supported sensor units and modules for this StickC+2 board. So, there are different kinds of hats and unit series products supported by this board. You will find them on M5Stack's website. These tiny modules and sensors have unlimited creative potentials. There are limitless possibilities and interfacing combinations to explore. You can try these products as per your project's needs. Okay, let's get back to our main guide. You will find information guides and resources on this documentation page. Let me show you. So here, you will see different tutorials to getting started with this module. Like, for example, generally, there are multiple options with which you can program this board. Among them, two are graphical programming platforms, UIFlow and UIFlow 2. These tutorials will introduce you to how to control the M5 StickC+2 device through the UIFlow graphical programming platforms. UIFlow 2 is next and advanced version of UIFlow 1. You can go to these tutorials to follow the guides to get started. We're going to use UIFlow 1 for a project. Then there is also a guide to get started using Arduino IDE. So, this tutorial will introduce you to how to control the M5 StickC+ device through the Arduino IDE. Please note, we can also program the M5 StickC+2 with MicroPython and CircuitPython, as it's based on the ESP32 Pico V302 chip, which is a common platform for MicroPython development. Okay, now let me show you some interesting features of M5 StickC+2. First, it is based on ESP32 Pico chip, so it supports Wi-Fi and Bluetooth. Then, it has built-in 3-axis accelerometer and 3-axis gyroscope. Then, it has integrated infrared emitter. It also has built-in RDC, real-time clock. Also, an integrated PDM microphone. Then, it also has integrated passive buzzer, which will be more useful for notifications. there are 3 user buttons, 1.14 inches LCD display, and power or reset button. To provide standalone power solution, this board comes with 200 mAh lithium battery with built-in charging support. With these all features, potential applications areas for this device are mainly in wearable devices due to its compact nature. Then in IoT controllers, STEM education, DIY projects, smart home devices, and so on. On this wiki page, you will find more information on specifications of this device. Then, how to use guides, schematics, pin maps, data sheets of the components included in this device, for example, IMU sensor, RDC, etc. Then in softwares, you will find library for Arduino and the test firmware or StickC+2's factory test firmware. So you can explore more on this page about different specs of this device. Okay, now let's see about next important hardware device which we are going to interface with this M5 StickC+ development board. So this is a unit GPS module. On this wiki page, you will find all information about this module. So as they said here, Unit GPS is a satellite positioning unit. It integrates AT6558 high-performance BeiDou navigation chip and the MAX 2659 signal amplification chip, providing high-quality satellite positioning services. AT6558 is a high-performance navigation chip that supports multiple satellite navigation systems. It can receive satellite signals from 56 channels and simultaneously receive GNSS signals from 6 satellite navigation systems, achieving combined positioning, navigation, and timing to obtain accurate global location information. This chip can quickly and accurately locate in areas with weak signals such as cities, canyons, under elevated roads, and anywhere inside a vehicle. This module can be widely used in products like vehicle monitoring, bus stop announcements, vehicle navigation, ship navigation, and laptop navigation. So we will interface this GPS module with M5 StickC+ board using this Groove connector cable. Then we will program StickC board to display speed on its LCD display. For that, let me show you how we can program this project. As previously discussed, this board offers multiple programming options. These include UIFlow 1, then its advanced version, UIFlow 2, Arduino IDE, MicroPython, CircuitPython, and other alternatives. So, among the various options available, we will be utilizing UIFlow 1 for our project. So, to program our M5 StickC board for our GPS Speedometer project with UIFlow graphical programming interface, we need a setup software development environment. Let me explain this further. So for this, let's go to this guide, which is Quick Start Guide for UIFlow 1's Web IDE. As they said here, UIFlow is a graphical programming IDE that everyone can easily use, supports wireless or wired program push. Program can be run by clicking on it. No need to compile repeatedly. It supports more than 100 M5 hardware peripherals and sensors, supports one-click addition and expansion, effectively assists in product prototype construction, and accelerates the development process to final productization. In this tutorial, we will introduce how to burn UIFlow 1 version firmware on your M5 stack device and use UIFlow Web IDE for secondary development of the product. So the interface of UIFlow 1 Web IDE will look something like this. Let's see overview of the steps which we are going to carry out. First, we have to install M5 Burner, firmware burning tool. So what is this? M5 Burner is a unified firmware burning tool launched by M5 Stack. Through this tool, users can easily burn UIFlow firmware and write Wi-Fi and other configuration information together during burning. So to use this graphical web IDE, which is called as UIFlow, to program the M5 StickC+2, first we need to flash UIFlow firmware into our development board. And the M5 Burner, the firmware burning tool, will help us to do that. So, we have to first download and install the M5 burner on our laptop or desktop. Okay, then next step is use M5 burner to burn the firmware of the corresponding device, configure a Wi-Fi connection for the device, and obtain the API key of the device. So what is API key and why we need it? As they said here, API key is the key used by UIFlow to distinguish devices. This key will be generated when the device completes UIFlow firmware burning. UIFlow Web IDE implements remote push of the program by specifying the same API key as the device. Once we do all these settings, then we can open UIFlow Web IDE in any web browser. Then, select the corresponding device option and fill in the API key of the device. Once you do that, your device will get connected to the Web IDE. And then finally, you can use graphical block-based coding to program the M5 StickC Plus 2. Alright, so let's see how we can practically do this all setup. First, let's download and install the M5 burner tool on our laptop. So, as they have explained in this second section, please click on the button shown below to download the corresponding M5 burner tool. Please download as per the operating system you are using, like Windows, Linux, or Mac OS. So we are on Windows operating system. We have already downloaded it. Let me show you. So here is the one. You can see. Now let's extract the zip file and install the tool. Just follow along. Okay, now burner tool got installed successfully. Let's get back to the documentation guide which we are following. So here, our first two sections are completed. The third section is about firmware burning and running program. So you can see, here they have given list of devices and their corresponding tutorials of burning. We will select our device, the StickC Plus 2. Let's go to its related tutorial. Let's open it in new window. This is tutorial of StickC Plus 2's firmware burning and program pushing. So you can refer this for more information. They have given thorough tutorial with screenshots and steps. We will do it on our system. You can follow along and replicate it. Let's open M5 burner tool. So, this is M5 burner, the firmware burning tool of M5 stack. This is the interface. On the left-hand side, you will see list of different M5 devices, like Core 1 and 2, Core S3, StickC, Atom, Stamp, Dial, Cardputer, and so on. You can select according to your available device. RM5 StickC Plus 2 comes under StickC category. So, we will select StickC. Then, here on right-hand side, you will see list of all supported firmwares, like this. In this list, you will see different firmwares supported by StickC, like UIFlow 2 for StickC Plus 2, UIFlow 2 for StickC Plus. Then, M5 StickC Plus 2, user demo firmware. Then, M5 StickC Plus factory test firmware, and likewise. Here in the search bar, you can search any other firmware you know about. For example, Nemo, Marauder, CatHack, etc. By using this checkbox option, you can also filter out only official firmwares. Please note, as our device's core family is StickC, you will see here all kinds of firmware supported for StickC, StickC Plus, and StickC Plus 2. Comes under StickC core category. If you select Atom, you will get firmwares related to Atom family. Let's find UIFlow for StickC Plus 2. So this is a UIFlow firmware for Stick C+2. You can see this is official firmware by manufacturer, the M5 stack. Please note, UIFlow and UIFlow 2 have different firmwares. Don't get confused between them. As they said here, this is developed based on MicroPython 1.12 for M5 Stick C+2 device. All right, now on the right-hand side, you will see this drop-down option. From that you can select your desired version of firmware. It is recommended that you should select the latest one. Then you can click on this download button to download that firmware into your computer. Please note, this will not flash your device with that firmware, but it just downloads it into local storage. So once it gets downloaded, you will see this successful message. And 3 more buttons will get appeared here, like these. You can remove, configure, and burn the firmware using these buttons. So, please note very important thing. Here, you must have to configure the firmware before burning onto your device. Let's do that. As soon as you click on this configure button, new window will get open, asking you to select the serial COM port. So, this is a serial COM port to which our M5 Stick C device is connected. We have not connected it yet. Therefore, it is showing only COM1, which is not our device. Let's connect M5 Stick C+2. As soon as you connect your Stick C device, you can see another COM port will get listed here, like this. You can see our Stick C+2 device is currently running a factory demo firmware. All right. Now let's select the correct COM port and click on this load button. This will open UIFlow's firmware configuration window. Please note, this is a very important step. On this window, you will see different parameters and configurations, like your COM port number, MAC address of your device. This is a unique address or ID for each of M5 stack device. Then, here is the API key. We have discussed about this earlier. You can always go to Reference Guide of Firmware Burning Tool for more information. Let me show you. So you can see this screenshot. As shown in here, you have to copy your API key from here and keep other settings as it is. So we need to copy and save the API key, since we will need to use it to connect our device to UIFlow IDE. As they said here, after configuring the device for online programming mode, we need to use the API key to establish a connection between the device and UIFlow, allowing it to push programs to the specified device. I will let you know where we are going to need it, but for now, just refer the screenshot. Okay, now let's get back to Burner Tool and see the other configs to flash the UIFlow firmware. Okay, next, here, you have to keep Start Mode as Internet Mode and Boot Menu to show, like this. Then down here, you have to enter your Wi-Fi credentials, SSID, and password. Once you've done all the configs, click the Save button to save it. Configuration saved successfully. Let's close this window. Okay, now once the configuration is done successfully, you can click on the Burn button to burn this firmware onto your M5 device. Again, on next window, it will confirm the COM port and baud rate. We will keep baud rate as default. Please note, here you can use this Erase button to erase the flash of M5 Stick C device. But we're going to flash the UIFlow firmware, so we will click Next button. Next, it will re-verify the Wi-Fi configuration. Then click Next. Burning process will get start. You will see its progress on this window. Once the burning gets successful, you will see this green button. Please note, if you get error at this stage, then you must have missed some configuration, like correct serial COM port or baud rate, or you may be missing the drivers for this device. If you are on Windows or Mac OS, you can manually install the drivers. Let me show you. So here, You can download the driver packages as per your operating system. Please note, this step is only for those who gets driver error issue during firmware burning step. Okay, now next step is to going to UIFlow Web IDE and connect our M5 Stick C device to it. So, you can follow this guide for reference. Let's open the IDE. This is the one. At first, it will ask you which version of UIFlow you want to use. We have to use UIFlow 1, since we have installed its firmware onto our M5 Stick C Plus 2 device, and it is also listed in its supported devices. Let's select it and go ahead by clicking Confirm. On next window, you will get Quick Start Guide for UIFlow interface. You can go through it for more information. Here you will get all the information, right from the firmware burning to development and interface settings. Please go through it. It's easy, intuitive, and explained in simple steps with relevant screenshots. Alright, now let me show you important points related to our project. First, let me show you how you can connect your device to this IDE. Okay, so we need to sign in first with our account details. If you have not created your account yet, you can click here to create new one. Okay, so we have now logged in. Next, let's select the device. In our case, we are using M5 Stick C Plus 2. For that, go to this 3-bar icon in top right. Here you will get Settings option. Once you clicked on it, this settings window will get open. Here you can see different M5 stack devices like Core, Fire, Atom, etc. We will select this yellow one, Stick C Plus 2. After that, pay attention, here you have to enter the API key which we have talked about it earlier. We have asked you to save it for future use. You have to enter that key here. If your M5 Stick C device is already got successfully connected to cloud internet via Wi-Fi, then you also can view that API key on your device. Enter the key and click on Connect. Your device will get connected to Web IDE. You can verify it here. Bottom left of this window, it says Connected, like this. As you can see, now our controller board is connected. Let's add our next device in the project, that is GPS unit. Below this device view, you will see these 3 options: units, hats, and stamps. For M5 stack development boards, there are different kind of interfacing devices, sensors, modules are available. We have seen that earlier. Now, for our GPS unit, we have to go to Unit section. Then, search for GPS. This is the GPS unit. Let's select it and load it. So now GPS unit got listed here. And you will see its related blocks in block section. You can use these blocks for different GPS-related programming. Now let me load our graphical block-based program of the project. Instead of building from scratch, we'll just load it to save the time. We will share its M5F file on GitHub repo of this project. You can download it and directly import it here in Web IDE. This is a graphical representation of code of the project. You can see its Python equivalent version in Python tab. This program is simple and self-explanatory. You just need to understand the functions of these different blocks. Just like Arduino program, there are 2 loops, setup and main loop. In setup, there are initializations and variable definitions. We initialize UART, GPS with time zone. Then some variables are added for velocity. In loop, we just calculate speed and trigger the buzzer notifications for overspeeding. Okay, this was all about the program. You can explore more if you want. You can add more GPS functionalities. You can also design your own screen using this LCD screen editor. Now, let's see the demo. Please note, we need to be outside in open space to get GPS signal. For that, we have tested this project in running car on highway. In this way, we have seen demo of DIY project GPS Speedometer. In our upcoming videos, we will see more content using this M5-stick-C devices. Stay tuned for more projects and tech updates. If you face any difficulty in replicating our DIY projects, feel free to ping us on Telegram or WhatsApp. You can also send us email at info@maketoexplore.com. We would be happy to help. Thank you.